Now we're going to look at simplifying rationals, simplifying fractions. Now, I do understand that there is a way to do this where you could just divide by 2, top and bottom, and you get like 7 over 25, and then you're going to take a look at that. Can any of those things be divided? Or here you could divide by 3 and divide by 3, but maybe you could divide by 2 instead. Or maybe you can divide by 6 or 9. And so there's ways of doing this. So what we're going to do is use prime factors to do this. It might seem like more work for these simple questions, but it's actually very helpful for the larger questions. One of the other things that is going to be useful is that some of these numbers, I think somewhere in there, we might have already done. So if there is a number like 84 or 120 or 770 that we've done up here, then you can just use that and copy that down below. So you don't have to redo all the work. And I don't know if there's any that match. There probably is in the worksheets. And in that case, it's, again, like I said, copy. So what do we have to do first? What the plan is, what the hope is, that we're going to take 14 and we're going to do a little prime factor tree, and then take 50 and do a prime factor tree. And then we're going to rewrite the equation, or the expression there, as a product of primes. So 14, easy enough, 2 times 7. This, I like this because this is a 10, so a 5 and a 10. And this 5 can get carried down, and this 10 can be a 2 and a 5. So what we do is we rewrite 14 as the product of the primes, so 2 and 7. And then we write 50 as the 2, 5, and 5. So I just copied this up here, and then I copied this down here. Now you can take, I use a different color pen, and I had to cancel out anything that is common on top and bottom. So there's a 2 common with 1 on the bottom. That's the only thing that's common, so I'm left over with a 7. And on the bottom, I'm left over with a 5 times 5, which is 25. And that is our reduced fraction. So that's how we're going to be doing it. Like I said before, there could be a faster way for something like this, but we're just trying to find a bit of a pattern or a rhythm. So I'm starting with some easier ones, and then they'll get progressively more difficult. So take 36 and 45. So we'll take 36, or it's a little bit higher here. Take 36 and 45, and we will write them out. So 36 is going to be 9 times 4. 9 is a 3 and a 3. 4 is a 2 and a 2. So I can write that right away, actually. 2 2s, 2 3s. And then 45 is going to be a 9 and a 5. And the 9 is a 3 and a 3, and you can bring down the 5. So I've got 2 3s and a 5. Then I took a different color marker here. I canceled out, there's 1 3 on top and 1 3 on bottom. Another 3 on top and another 3 on bottom. That is all that is common on top and bottom. And then you just write what's left over. 2 times 2 is 4, and there's only a single 5. So 4/5 is our answer. Okay, here for the next one, the numbers are getting a little bit larger, but we also have some negatives. So the first thing I'm going to notice is that whenever I have 2 negatives that are multiplying or 2 negatives that are dividing, that will cancel out. So 2 negatives become a positive. So I'll just make those both a positive, and then they're just gone. And like I said, the numbers are getting a little bit larger. So we have 72 and we have 180. 72 is going to be 9 times 8. And 9 is going to be 3 and 3. And 8 is going to become what I like to call, or do 2, 2, and 2. And so that looks good. I got my 2s, I got my 3s, so I can do this. This is nice. This is going to be one of those 18 times 10 because of the 0. 18 is going to be 6 times 3. 10 will be 2 times 5. So the 5, 2, 3, that's good. Okay, so this needs to be a 2 and a 3. Carry down the 3, carry down the 2, carry down the 5. So on the top, I'm left with, I have 3 2s and 2 3s. And on the bottom, I've got, I guess, 2 2s, 2 3s, and a 5. So 2 2s, 2 3s, and a 5. And I can cancel out things on top and bottom. So I've got a 2 and a 2, 2 and a 2, 3 and a 3, a 3 and a 3. So all I'm left with is this 2 and this 5. So my answer is just 2/5. So I don't know if that's any more difficult. The numbers were a little bit larger, but the process was the same, other than, I guess, this double negative. Now this is a single negative, so only one negative means things stay negative. They have to be in pairs in order to cancel. And that only happens when you multiply and divide, and I am dividing here. So my answer will need to make sure to be negative. So I can't do anything with that now. 84 and 98, so I can do 84. That can be divided by 2, but it can also be divided by 4, I think. So 4 and 21. 4 is a 2 and a 2. 21 is a 3 and a 7. And those are all the bottom. So now I got 98. That's 49 times 2. And that's going to be a 7 times 7. And I guess I can carry that 2 down. So on the top here, I've got a 2, 2, 3, and a 7, and I still have a negative, so I'll throw that negative up there as well. In the bottom, I've got a 2, 7, and 7. 2, 7, and 7. So cancel things out. There's some 2s I can cancel out, and there's some 7s I can cancel out. Now all I'm left with is a 2, and a 3. So a 2, a 3, and a negative. So 2 times 3 is going to be 6, but then there's the negative, and just a 7 is on the bottom. So I like these questions because they're a little bit larger, and I like the fact that there's some negatives in there. But this whole process is actually quite nice because it allows us to simplify fractions without a calculator relatively quickly. So I can just make up these trees, cancel out tops and bottoms, and without a calculator, I can simplify to lowest terms. So I've zoomed out there if you want to make any notes, and then we can move on to the next questions.